All right, let's take a look at an example so we know how to actually do a chi-squared test with a sample. So we've got an example here, and I've been using the M&Ms as our example because I knew we were going to be leading into this. According to the M&Ms website in 2000, in the year 2000, the color distribution for M&Ms was brown 13%, red 13%, yellow 14%, blue were 24%, and the orange ones were 20%. Green was 16%. So I actually did this last year with my AP Stats class. Sorry, we ran out of time, but you guys have had plenty of M&Ms. So we actually did this activity, and there were 1,200 M&Ms. It was a big class. That we took a look at, and we counted them out, and we got a total sample from bags of M&Ms. So go ahead and take a moment to write that down. Now let's go ahead and take a look at how to do our state part. So we're still doing state, plan, do, conclude. Nothing has changed. But our null hypothesis is going to just be that the M&Ms, that nothing has changed. That is a goodness of this test. Nothing has changed about the proportions listed above. So that's going to be my null hypothesis, this up here is the true distribution of M&Ms. So the color distribution of M&Ms is the same as it was in 2000. And you don't have to rewrite it. I'm just going to say listed above. Done. Okay? That's all you have to say, is that you believe that there has no change has occurred since the year 2000. That's our null hypothesis. So our alternative is we don't believe that. We think it's false. All right? The color distribution of M&Ms is not the same as it was in the year 2000. Oops, 2000, not 200. All right, so that's it. So that's how you write your null and your alternate hypothesis. Now, how would you know that you needed to do a chi-squared? Because they're asking us about 6 categories of proportions, not just one category of proportions, not just are the browns still the same. It's all the colors together. All right, so now let's do our plan. So we always start with random. Okay, so we're going to assume the M&Ms in our sample are a random, okay, distribution of the population, or a random, I should have said, I apologize. No, I think that's good. Random distribution of the population. Okay. Or I guess I could have said random representation of the population. Maybe that's the word I probably should have used there. So yeah, if you want to change that, distribution to representation might not be bad either. But you've checked it, so we're good. All right, 10% rule. All right, do we have, okay, all right, can we say that 1,234 is less than or equal to 10% of all the M&Ms in the world? I believe so. Yeah, I think so. I think there's probably more than 12,000 M&Ms in the world. So we're good. All right, 10% rule. Good. Okay, large counts. Do we have more than 5 samples in every category? Yeah, the smallest one is 114. I would say that is definitely greater than 5. So we're going to say that n is less than or equal to 5 for all M&M colors. Oops, I forgot the M. Colors. Okay. All right, so we're good. So what do we proceed with? Okay, so since the conditions are met, we will proceed with a chi-square. You can write the symbol here too. It looks like this, so chi-square. You could do it that way. Test for goodness of fit. All right, so since the conditions are met, we would proceed with a chi-square test for goodness of fit. All right, I took a moment to pre-fill in this table and zoom in just a little bit so you guys can see this. What we're going to do next is I took my observed values that I got from the top here. All right, yeah, I got those from there. And I went ahead and filled in all those 6 numbers again. And then what I did was I took the expected, so the proportion that was listed in the first prompt. So I wrote down what all my p-value, or proportions, my hypothesized proportions should be. So for the 1, it should be 0.13, 0.13, 0.14, and etc. I multiplied all of those by 1,234. Hey, just a quick question. Where did I get that 1,234 from? It was my total in my sample. So this is how many I should expect to get if these really were the true proportion. All right. My residual, of course, is just subtracting the 2. So what I want you to do is go ahead and take a moment to copy all that down. Oops, sorry about that. And I'm going to pause it if you need to back up, and then just hit continue when you're ready, and then I'll fill in the rest, the next couple of columns. All right, so my next 2 columns that I filled in here already, I've got basically I just found the difference observed minus expected, then I squared all those numbers, and then the component is we're going to take this last column that I filled in, and we're going to divide by the expected value. Okay, so this is how we're actually going to get our chi-squared value. So let me fill those in for you. And while I'm filling those in for you, why don't you go ahead and fill out the rest, those 2 columns right there. Okay, so after I divide, that's an 8 by the way, that's hard to see. Go ahead and copy these values, and then you find the sum of this final column. That is actually my chi-squared statistic. This is it. Okay, so this is chi-squared. It's just like your t. It's just like your z value. That's your chi-squared score, if you want to call it that. And that's how you calculate it by hand. It took a long time, I know, but guess what? We've got calculators, so there is a little bit easier way to do it. I'll show you that in a moment. Okay, so degrees of freedom. Ooh, let's see if you were paying attention to the first part of our notes. I'm going to ask you right now, what is the degree of freedom for this problem? All right, hopefully you answered. It's n minus 1. The number of our categories is 6, so it's going to be 6 minus 1, so our degree of freedom is 5. Okay. So we want to use, we want to use table C to find out our, probability, to find the significance. Okay. All right, so here we go. So what I'm going to do All right, so we're going to find the probability that this happened. Okay, so we've got 5 as our degree of freedom. Our number was 122.07. Okay, so 5, and I'm going to go up to Haas and try to find 120. It's not on there. Okay, so if I look up here, this would be my p-value. But our test statistic is so huge that it's extremely unlikely that it's so huge we can't even find the p-value on this table. It's too big. Okay, so chi-squared is so extreme. Okay, the p-value is not on table C. Okay, so we're going to use a calculator instead to find the p-value. So here's how you would use your calculator. Okay, so I've got my calculator up here. I've got just a calculator page. I'm going to go ahead and go to Menu, Statistics. We know we're doing a statistics test, and you can see right there, chi-squared, GOF stands for goodness of fit. So I'm going to select that one. Okay, now it asks you for your observed list. There's 2 ways you can do this. The first way is you can put this into a list and table, give it a variable, all of those things. This is a very short list, so I'm actually just going to put it in set notation. So I'm going to use Control, close, and then I'm just going to type in my observed values. So I had 173, 119, 114, 247, 257, and 324, and it's all within those square brackets. Same thing with the expected list, but like I said, you could totally put this in a list and spreadsheet too, but it's a pretty short list. So 160, 160, 173, 296, 247, and 197. Okay. Degrees of freedom, remember, was 5. We had 5. Now, I don't know why it can't calculate that itself, because it should be able to see that I only had 6 categories there, but it wants you to do it. So our degrees of freedom were 5. So say OK. And bam, there's my chi-square value, which we did get correct doing it by hand. There is my p-value. Look at how small that is, because remember that e to the negative 24 means that there are, okay, all right, so there are 24 zeros after that decimal. That's insane. Okay, so here's what I'm going to write on my paper. All right, so let me switch over to that. On the paper, I'm actually going to say, okay, so my chi-squared, because honestly, if I were doing this on the AP exam, I wouldn't do this whole big table. I would have just typed it all in my calculator. So I would write down, chi-squared equals 122.07, all right, the p-value, and I'm going to write down the e, okay, or that it's the probability that chi-squared is greater than or equal to, okay, it's going to be greater than or equal to 0. Actually, you know what? Is not equal to 0 is really what we want, because that's going to be, it's the same, but there were no change. Okay. All right, so probability is equal to 0, meaning no change. All right. But basically what we're saying, the probability that there was no change was 1.1415. You can write e to the negative 24, and you just need to say extremely small value. Okay, so it's okay to write your calculator number as long as you note that, hey, you know this is a super small number. This is not 1 point. You can't have a probability over 1 anyways. So as long as you write that that is small, because, you know, you don't want to, you know, be that fool you're wrong. You just lost points. All right. Last thing, we're going to conclude. Since the p-value, we're going to say, since the we don't even need to say what it is because we said it over here. Since the p-value is extremely small, we reject HO, the null hypothesis. There is significant evidence the color distribution of M&Ms is not the same as in the year 2000. All right, whew, that's a long problem, but mostly because I did a lot of explaining there. It really would not take you that long. Okay, so let me wrap this up. Sorry this video is really, really long, but I'm almost done. You have on the next page of your notes another example completely worked out. Okay, so the next page of your notes, all right, shows this problem with fruit flies. Okay. All right, so there's a problem with fruit flies. All right, and it shows you how they calculated the chi-squared by hand. Okay, how you do it, p-values from a calculator. Oh my gosh, it's like 0. Okay, so it's extremely small again, and you're going to reject the null hypothesis. Then on the back page of your notes, okay, is one to try on your own. I will do this one, and I will copy it and put it on Google Classroom, the key, so you can check your work. All right, that was long. I'm so sorry. Well, not sorry, because you learned a lot. It's good. All right, I will see you guys back in stats class.